Okay, we're going to do a sample Y delta question here. And this type of question has two loads on the same circuit. The first load is 3 coils, so 3 30 ohm coils. And those coils have a 40-degree lag. So they're at a 40-degree lag. And they're connected in Y. The next one, load on that same circuit, is 3 30 ohm resistors, and they're connected in delta. And they are connected to a 3-phase 208 volt supply. The question is, what is the total current of the circuit? So what I like to do is always draw out that circuit first, and we can start labeling some stuff. Okay, so we've got a 120 208 supply. We've got each one of these coils has an impedance of 30 ohms, and they're at minus 40 degrees. And so all three of those coils are the same. And over here we have 30 ohm resistors. So each one of these phases has a 30 ohm resistance in it. So that's all resistance. Okay, let's go ahead and let's start figuring out some of the values for the Y load, because what we do have to get to is we have to add the line current of the Y and the line current of the delta to get the total line current. So we are after, if we put an ammeter right here, what's the total line current? So that would be the sum of the currents going down to the Y and the sum that keeps going down to the delta. All right, so let's begin on the Y circuit. So for Y, let's remember the rules of Y. So in that case, we know that V phase or V line is equal to V phase times root 3, but they've already given us the phase voltage. And we also know that line current and phase current are the same value. So we have enough information here to solve for the phase current. I phase is equal to the voltage of the phase divided by the impedance in each phase. In our case, our phase voltage given is 120 volts divided by the 30 ohms, and that comes to 4 amps. Now we know that in Y, line current and phase current are the same value, so that's 4 amps. Now if we look and remember back that our reference in delta was our line voltage, which is the same as our phase voltage. And our reference in Y was usually the phase voltage. But because we have both of these on the same branch circuit, we have to change the reference of the Y to the line voltage. So here's our phasor diagram. We have to put VAB, our line voltage in Y, at 0 degrees because we have the same line voltage over on the delta. And now they're both referencing the same voltage vector. When we do that, we have to plot the phase voltage down 30 degrees. So normally that would be at 0, but now it's plotted at 330. So we can go ahead and figure out what angle this current is going to be at. Remember, phase and line are the same thing. So if I wanted to figure out line current IA of the Y, I know it's 4 amps, the same as the phase current. And I'd have to plot it at 330 subtract 40 degrees, which is now 290 degrees. So with the line voltage as a reference, our line current will be at 290 degrees. Okay, so we have the line current of the Y. Let's go ahead now, and there it is. Let's plot it out. So we're at 290 degrees. Let's go ahead and now let's have a look at the delta. Well, if we recall the rules for delta, in delta, we say that, well, V line, well, that's the same as V phase. And when we have a balanced circuit, we say that I line is going to be equal to I phase times root 3. And we can also say that I line in balanced lags I phase by 30 degrees. And these rules, these two rules, only are for balanced only. Okay, we have 330 ohm resistors. We're good. We're balanced, so we can apply those rules. So let's go ahead and let's first start off by figuring out our phase current. I phase would be equal to the voltage of the phase divided by our resistance in this case in each phase. So that's 208 volts divided by 30 ohms. And that's going to come to about 6.93 amps. Okay. Now we can calculate line current. Line current is going to be equal to phase current times root 3. So that comes to 6.93 times root 3. And that value should be about 12 amps. Okay, let's draw a little phasor diagram and have a look. So we have to use our voltage VAB as a reference. That's phase voltage or line voltage. We know that the phase current will be right in phase with VAB at 0 degrees, and that when we have a balanced circuit, line current always ends up 30 degrees behind phase current. Right? I line lags I phase by 30. So that 12 amps, we're going to plot it 30 degrees behind our phase current, so that would be right at 330 degrees. Let's have a look here. There's our phase current, IA to B. 30 degrees behind it is going to be our I line. So that's our IA right there. Okay, I think we're ready to add these two vectors up. We have the line current from both of them, so let's go ahead. And I usually write it out like this if I'm working with just line A. IA total is equal to IA of the Y plus IA of the delta at their respective angles. So if we add that up, we've got 4 amps at 290 degrees plus 12 amps at 330. So when I add this up, it should come out to about 15.28 amps. And it's going to be at negative 39.7 degrees, which would be about 320.3 degrees. So remember, when your calculator gives you a negative value, you have to subtract that from 360. Hopefully this helps, and we're going to see you on the next video.